Hello and welcome back to Craig and Dave Unscripted. So we're here, we're at the end of the journey, level 9. If you've been with us on this journey, you will know that we've been joined by Harry and Anna, who I'm bringing on screen now. Level 9, we're here. If no one knows what we're talking about, by the way, where have you been the last few months? You've got 8 or 10 more videos to watch. But yeah, so it's exciting stuff. So today we are going to be looking at traversing the depths of 2-dimensional lists. And I'm handing over to Anna to give us a bit of an overview of what today's session is going to be about.
Well, I think that says it all. We look at 2-dimensional lists in this level, quite in depth. I feel like I say this a lot, but an in-depth look at them, lots of different skills, which Harry will go over a bit more. And I think later in the video, Dave will have a bit of a talk about why we've decided to separate 1-dimensional lists and 2-dimensional lists, because I know some people might be like, but why have you done that? They're like almost the same. The list, they've got lists in. But Dave will discuss that later, and it's a really good reason, and we've really thought about it. So it's a good level. And I also think, I'm going to say it again, the projects do get better. It's not the capstone project, but one of the learning projects with the walkthroughs is 4 in a row, which I think is a classic game. I made it with my dad. It's absolutely classic. And it's quite nice that you get to make an actual game that people actually play in the real world, I think. So really combining your skills and making something that like your friends will know how to play, your family will know how to play. So I think that's really nice. And I will hand over to Harry for a more in-depth look at exactly what is in this level.
Right, thank you. And I don't think I need to explain really what this page does, because everyone's probably seen it, well, for the 9th time now. But I've noticed there's a quiz game, and I thought to mix this up, perhaps, since I don't know the answers to any of these, Anna, perhaps you'd like to try and answer this question. So,
I don't know any of the answers. I don't remember.
Snail can sleep for 3 years, true or false? This is the 2-dimensional.
Why can't we play this?
Oh yeah, you can play it.
Yeah. Right,
Can we zoom
Craig,
in a little bit for the elderly on the call whose eyesight is not quite so good?
Yes, there we are. Hopefully it's pretty big now. I mean, I can read it out if you like. Right. A snail can sleep for 3 years. True or false?
That's got to be false. Surely they don't hide.
Yeah,
them.
false.
That's false.
I think it'll get stood on before it woke up. Oh, apparently it's true. I didn't know.
Every day's a school day, everyone. Biology teachers there going, what do Craig and Dave know?
We probably didn't have time for many more, but I'll give you one more, shall I? Right, the memory span of a goldfish is only 3 seconds long. True or false?
Hang on, because Dave's going to know the answers to this because he's a huge aquatic fan. I think that's one of those urban myths that everyone thinks is true and everyone says is true, but is actually false. I think everyone says that, but I swear I've heard on QI or something that that's a misconception. I think it's false.
You're right.
Yeah.
You're proud of me, Dave.
A long memory, but hey, you're right. I'm not getting into my hobby.
Right, I suppose we should probably stop looking at it there, but there are some good questions in that quiz. So if anyone would like to play it, well, you can make it yourself, actually, and you can add some more of your own. And that's the capstone project. So we'll talk more about how that's actually made once we've, gone through the level, which I think we ought to do at this point. So we'd start off by asking the big question, I suppose. I mean, what are 2-dimensional lists? And we just cover that as we usually would with an example of the code here. And then we also show you jagged lists, because I know you can come across those. Perhaps you don't really want to be coming across them, but if you do, then you'll know what they are. Then we basically go through how you can create 2-dimensional lists, how you can go through them as well using for loops in order to create them as you go. And there's a table here, trace table, in fact, which I'm doing at the moment in my A-level course. Not a massive fan personally, but I know we do have one, and it walks through this program here. So I think that might help some people to visualize it, just if you want to see how it works. And actually, I think this is maybe one of the only examples where I can imagine a trace table might actually make things easier to see, perhaps. Controversial opinion there. Yeah, I know, sorry, on the computer science channel, but They're really confusing and unnecessary in the vast majority.
Oh, controversial. I need a little buzzer that I can press every time someone says something a little bit,
Cut this bit out.
No,
People writing
perfect.
into you complaining. Not necessarily the views of Craig and Dave Limited. Yeah, anyway, there is a trace table. So some great computer science stuff there always seems to come up on exam papers, which is always a delight. Anyway, following on from that, we look at accessing data in two-dimensional lists, which I think makes sense since we've created them. And actually, this is quite a good graphic that I think Anna might have made using Google Docs.
Probably using Google Docs. Not the finest graphic.
I mean, it does the job, I think, and it shows you how to index them, because I know it can be a bit confusing to visualize it. So, I mean, there's a trace table for the trace table people on the last page. Now we've got this. I don't quite know what you call it, diagram, perhaps. But I think by seeing all these examples, hopefully by this point, you'll be getting an idea of how a two-dimensional array looks. And it's not really that complicated. Like, as long as you know in your head what it looks like, you'll be absolutely fine. And then we look at how we can index them. And then once we get to that bit, we're looking at iterating through them. So it's probably one of the most complicated bits to understand, I would say, in the programming course for a lot of people. But again, not that bad once you've had a few examples of it. So, we'll show you how to use a for loop to go all the way through that two-dimensional list. And then once we've done that, it's when we get onto the project that Anna was mentioning, 4 in a row here. I think it might have been formerly called Connect 4. It was in our version. And I think we realized there was potential copyright issue there. So yes. Having 4 in a row. But that's a really good example, I think, of how it can work. And we do actually walk you through all of this. I know it's a really long explanation.
It took me a really long time to write.
I remember being there whilst Anna wrote it, and it did take a long time. But we got there. So you can basically go through every single line of code in that project. I mean, well, as with all of our walkthrough projects, but I think especially with like a big complex one like this, it's really good to see it modeled and understand, how it's done, just so that you understand every single line of code that's in that program. And then by the time that you get onto the capstone project, it's taken me a long time to scroll through this tutorial. But when you do eventually get onto the capstone project and you've made that, you'll be really ready, I think, to tackle this, hopefully, and try out making your own quiz go. And you can see all the answers are on here, actually. Some good quiz questions there. I don't know where they've come from, but I think they're really fun. So have a play of those. And if you like them, what you can actually do is you can make your own. So if you really get time and you want to find out some more fun facts, that might be a nice way of extending the project. But of course, what we'd advocate for, and I'm not sure how much we've really looked at these, but we've actually got some extensions in here, and they'll give you some more ideas of what you could do to adapt the code. So, maybe you could modify it so that it would tell the user, a little bit of feedback about what they've tried to enter. You could give them a score as a percentage, so a bit of maths in there, and it all ties in really nicely to the skills that we learned in the previous levels. So, it's a whole level on sort of mathsy skills that I think will come in very useful there.
And we were saying last week, weren't we, that you can easily extend any of these projects by applying skills that you've learnt more recently or before. And so with this, it's another good example. Your 4 in a row could easily be extended to saving the board state and reloading the board state if you wanted to introduce files in here, and then exception handling in case somebody's deleted the board. You could even put a little bit of encryption in there if you wanted to obfuscate the board position so it's not easy to kind of hack. You could also, if you wanted to, start looking a little bit towards artificial intelligence algorithms, only at a very simplistic level, but how could you play against the computer, for example, and introduce the concept of sort of easy, medium, and hard levels? There's so much you could do with a project like this to extend it.
And I think especially since it's like the last project in our course, if you really wanted to make something awesome out of it, you definitely could do, because it's a quiz. So there's so much that you could do just to take it to that next level. And I think, if you finished all the levels and you're feeling really confident with it, then perhaps this could be the project that you really spend a few more hours working really hard on and making it the best it can be. I think by doing that, like, versus just following what we've told you to do, I mean, you'll learn a lot more, I think, but also it's a lot more rewarding if you're making something because you want to make it or because you're interested in it, and not just because the scheme of work's told you to make it. So
yeah,
it's nice. I think that's the last project, isn't there?
Don't you think that's that's the truth of it there, Harry? This idea that if all you're doing is what your teacher tells you to do, you will learn a certain amount. But the real learning happens when you want to find something out for yourself. You've got the problem to solve. You want to extend the program in a particular way and you don't know how, but you're determined to work it out one way or the other and make it happen. And I actually think the strongest learning happens when students learn for themselves. Where's my controversial button? But you know what I mean? What do you think?
Are we asking me or Harry?
Well, anybody. I mean, I was asking Harry, really. I mean, from the student perspective.
I mean, I definitely agree with you. Yeah, it was just I heard controversial. I thought we were going to go back to the trace table conversation, but save that one.
Well, there's just this debate in teaching about student-led learning. You know, is it that effective? And I think it depends on how you
depends on the subject in a sense as well. But I think with programming, yes, it does. I think if you told me to go away and research some physics thing that I wasn't very bothered about, I might struggle slightly, but hopefully this is a bit more accessible. And I think because it's quite interesting innately because of the topic that we've chosen, you know, I can't see who wouldn't want to take this program and extend it. You know, it's not just for the computer nerds, because there are all kinds of people who do computer science GCSE, and it's a really nice project, I think. And it's also one you can play with your friends. So if you've made it successfully, then, you know, it's a really nice game to challenge your non-computer science friends to, and make them realize what they missed out on by not taking the best GCSE. So
yeah. I've said this so many times before. A lot of people very naively bucket computer science. It's a very heavily academic subject, and yes, there are obviously academic elements to it, as there are with all GCSEs and A levels, but they'll always go, yes, computer science is an academic subject. It's there with maths and physics and English. I would argue the other way, especially to someone who's deliberately arguing that, and say, no, it's a creative subject. It's there with music and drama and art. I mean, yes, of course. And there's academic elements in those subjects as well. I mean, you try doing a music A level and tell me that's not academic. So this idea, but it is creative. How do you get better at a musical instrument? How do you get better at drama or sport or whatever it is? It's the practicing, it's the doing, it's the creative element. And we've talked about that a lot. And Dave's nodding furiously. I know he agrees strongly, but that's what it is. You know, experiment, you'll find you'll enjoy it, you'll do a bit more, you'll get that buzz, you'll learn, and that's when the learning really happens. Your teacher is there to aid you, to guide you, to help you, to support you, not to do it all for you or to limit you. And you know, good teachers don't do that, and good students take something they enjoy and they experiment with it. Right, I'm going off on. I actually had an important question to ask about this. And Anna, you alluded to it at the start. So we've said before in this series that the levels and the order that the levels are introduced have been carefully thought about by, you know, both Dave over at Craig and Dave Time for Code and by Harry and Anna, and everything's done in a certain order. And some people may be asking, we first introduced lists, I think it was there, yes, way back in level 5, how to use structured lists. And it's here. All the way at the end of the course in level 9 that we talk about two-dimensional lists. So Dave, maybe you could just you know, cover what Anna was alluding to earlier. Why didn't we just introduce two-dimensional lists at the same time we were introducing lists to you in the first place? Because we did a similar thing with loops. Obviously, we didn't introduce them both together, we split them apart. Yeah,
well, there's two words, and I'll let you explain it, because you know I talk too much anyway. It's two words. It's about indexing and it's about nesting. And I think when you're at level 5, you just need to start to learn that you can group data together under a single identifier. And then in level 6, you can use a for loop to iterate through that list. And I think that's enough knowledge, because when you get to 2-dimensional lists and 3-dimensional lists and, well, X-dimensional lists, it's about indexing and nesting. So do you want to pick up the great academic debate about indexing, Craig?
Here we go. Is this the which one comes first, row or column?
Yeah.
Yes. So we see it a lot on forums. You know, you're declaring an array or a list in this case in Python, and you want to access it. And often, especially in exam papers, you know, you'll see diagrams of them drawn out. Which number comes first? Is it the row or the column? Am I going along the corridor and up the stairs? Like, there must be a right way. It's an abstract data type, and it actually doesn't matter as long as you apply it consistently. Now, I noticed actually back in your level, you were losing column and index. One of the things, it's fine as long as you then apply that consistently, which is what you then did in the follow-on. I was going to mention at the time, maybe we could just reshare that. It was where you had the big diagram come up, I think. You had an image. Yeah, there you go. So you put row and column, and of course you're presenting this as a diagram on the screen. So obviously we'll say rows go from left to right and columns go up and down, because that's what you do. So therefore, when you go down further, when you actually give your code example, there you go, we're saying, oh no, just up a little bit, just literally just put, there it is, 2-dimensional list, open square brackets, row index, column index. And as long as you're then consistent, then that's fine. But it actually doesn't matter. And there's an awful lot of confusion about this from teachers and students. I meant to say students and teachers. Was that kind of what you were alluding to, Dave?
Oh, absolutely, Craig. Yeah, if we just go back to put the diagram front and center on the screen a minute. Yeah, because then when you start referring to elements and you say, what is at index 2,1, you know, is that 3 or is that 1, depending on sort of how you read it? And, you know, with the way you've presented it here, there's a right answer to that. But yeah, it's funny because a lot of teachers don't have a background in the subject. They don't necessarily come to teaching computer science with a computer science degree or industry experience of programming. And they might have gone on an accelerator course or something that's there for teacher training. And you never really get taught the nuances and the real understanding behind computer architectures and data structures. So you only know what you've been taught rather than what the truth is. And in computer science, there's so much abstraction at different levels of understanding that what you might think is true is only true at a certain level of abstraction. And actually, if you go a bit deeper, what you know is not necessarily true. And this is a good example of that. You know, teachers will say, it's always row and column. And then other teachers will say, it's always column and row. And they'll cite how you draw graphs in maths and science and all sorts of other things. And it's all irrelevant. Craig's absolutely right. It's about consistency. It's about how you visualize the data structure. Because ultimately, to a computer, it's just a sequence of zeros and ones in memory locations. The only reason there's structure is because you have implied the structure on that data. And so it's an interesting one. And the second thing was just nesting. I mean, Harry was showing us examples of code where you've got a for loop inside a for loop. And you've probably done a bit of nesting in other programs before you got here, particularly the nesting of if statements and things like that. But for a lot of students, as soon as you nest a for loop in a for loop and you've got 2 different indexes on the go, their minds are just blown. And so I actually do think that's quite a hard thing to teach, even though it's an easy thing to show on the board. And we've all seen tables, and you can use a school timetable as an example, where you've got lessons and you've got days, and do you put the lessons across the top or do you put the lessons down the side, the days across the top or the days down the side? And it doesn't matter, does it? So it's a good example of how you can explain that abstraction to students. But as soon as you get to coding it, and you have to take that mental image that's in your head and actually turn it into commands and code, students just seem to find that to be a barrier, which is why we don't do it in level 5.
Oh, brilliant. Is there anything else, Harry, you wanted to cover at all with level 9? Or
not from me. No, I think we've gone through it all. But I mean, as I say at the end of every single one of these videos, it's a very nice level. I think it's just a good way of running the course off, really, to look at two-dimensional lists, because they might seem complicated and a bit scary, but I think once you get your head around them, they're actually quite nice. And when you see it come up on an exam, I think it's one of those topics where you might be quite pleased because possibly other people might be confused by it. But, if you know your stuff, you're not going to get caught out by it. So hopefully by doing this level, building two quite complicated projects, you'll be able to smash any exam questions you've got coming up relating to these. And yeah, you'll feel quite confident with them. So nice topic.
It should be pointed out as well. I mean, everything was covered here in level 1 to 9 on Mission Encodeable and Time to Code. Will give you the skill set you need to tackle everything in your GCSE. There won't be a problem that can be presented to you that you won't be able to solve. But as well as that, doing everything up to level 9 and practicing and expanding and doing projects from the other sites, it will give you a fantastic grounding and springboard if you choose to take this on to A-level. You'll find a lot of people who do A-level have not done the GCSE. It's not often a requirement. And I've taught students before who've started coding from scratch in A-level. It's perfectly fine. But you complete everything up here to level 9, get a good grasp and understanding, and you will have a fantastic grasp in your A-level. You'll find you're relearning things. You're like, I did this back at GCSE. The A-level courses all say need to learn about data types, iteration, count control loops. They'll take concepts further. Dave alluded to it last week. You learn about basic text file reading and writing. Well, we introduced that at level 8. You'll bring that with you to A-level, and then you'll learn about different file formats. You'll learn about JSON and XML and CSV files. You'll come back to arrays and lists, but you'll now be learning about them in 3 dimensions. But you'll have that starting foundation. So the journey doesn't end here, is what I'm saying, and it's an excellent springboard onto A-level.
And it doesn't end with the scheme either, I might add, because level 1 to 9 is what we've got at the moment. And as you say, it covers everything on the GCSE. If you can do all the projects in Mission Encodeable, then you should get the top grade. Dare I say it? You should get the top grade, really, at GCSE. But equally, there are plenty of projects in Mission Encodeable that are more suitable if you're not at that top grade. It's perfectly applicable to all learners in all levels. But it's not the end, because we have got some more levels to come. They haven't been written yet, but level 10 will be Turtle. And that's actually quite an easy thing, but it's only applicable to edXL. So we've kind of put that on the end. Otherwise, there would be students on other courses learning things they don't need to know. And then there is level 11, and in no particular order, that I think is going to be SQL and using databases in Python. So that's going to be good. And then we've got level 12. I'm losing count here.
Yeah, that's right. 12. Yeah.
Level 12, which is going to introduce object-orientated programming. So our intention is to get this scheme to go all the way to A-level. And then level 13 is going to be graphical user interfaces. So again, by the time you get to the end of level 13, you should be able to do a full A-level project. We haven't written those levels out yet, but there are plans for the future.
No, and it should be pointed out, Harry and Anna, thank you ever so much. Obviously, we rely heavily on them working with us on this, but it's probably worth mentioning if we haven't already. If you're watching this video pretty much as it comes out, Harry and Anna have our A-level students who have currently started year 12. So, phenomenal. You started this site, I think we said way back in introduction, back when you were 14. You're not 14 anymore. The pressures of A-level are upon you. So one thing we won't commit to, I'm afraid, is timescales for those. It is something we want to do. Oh, did my camera just go there?
It did freeze a little bit, but that's okay. It's recovered.
Yes, we are committed to doing them, but we won't commit to timescales. It's very important for Dave and I having said, I know teachers that Harry and Anna obviously put their A-levels first. Any time they're able to give us and helping expand Mission Encodeable and Time to Code, we're grateful for. But yeah, Harry and Anna, thank you ever so much for
one thing we have started on though, which we do need to thank them for, because they're already giving us code that we need to put into the website.
You're going to tell the community this now? Is this a reveal?
C# version. Yeah. C# version. Work on that has already started. So nothing's on the websites yet, but coming soon to Mission Encodable.
Never say coming soon. Never say coming soon. How long soon? Right. Okay. We could waffle on now. Any last comments from the two of you? Dave and I will just chat away otherwise if we're awful. Anything else you'd just like to say as we finish off this series?
Thank you very much. That's all I really have to say. But yeah, exciting things on the horizon. I shall look forward to it.
Thank you very much. It's very kind of you to put this on your unscripted. And yeah, as Harry said, exciting things coming soon or in the future.
Indeed they are. Yeah, this won't be the last you've heard from Harry and Anna. It's not the last we're working on. We've got lots of exciting things in the pipeline. And although we may not be back with video with them next week, we will certainly be back when we have something new and interesting to share with you all. So for now, thank you very much for having watched all these videos. If you haven't already, what are you doing? Go check out Mission Encodeable. It's great. Go check out Time to Code and enjoy your programming. For now, that's it from us. Thank you very much, everyone. Goodbye.